Welcome, welcome. How are you doing today? We are going to get into a discussion about Java and what it is. Also, I'm going to show you how to build your first program. And then, uh, see, Java, what is it? Build your first program. Last. Let's go over some characteristics of the course and some kind of, I guess, what I would call it norms, and course norms, and then let's see, kind of just maybe, I don't know. We'll see what happens. But I don't want to get to I don't want to do the boring stuff just yet. Let's get into why we're here. We're talking about Java. We're learning about Java. Well, what is it? And I want to spend some time on that and give you a little bit of some understanding of kind of where where we came from to get where we're at with Java. So that's going to be like, well, let's throw in some history here on this guy. Okay. Boy, that's wonderful. Okay. All right. And let's see. Yeah, what's Java? What is it? What built it first? And I just want to have some clarification points on what built it. And then what is the most important part about Java is it's intermediate, it's middle language. So I'm gonna let's pop in and let's talk to my friend Sandra and see what what she has to say. And I might let's just see. Let's see what she says. Oh, wrong mode. Wrong mode. Hey, Sandra, are you there?
I'm here.
Hey,
And don't worry.
no,
Hey
hold on.
there.
Let me talk. Jeez. Um, I am looking at into the Java language, and I want to know what language created Java.
Sure, go ahead. So, Java actually has its roots in a language called Oak, which was the original project name before it got renamed to Java. Oak was influenced by C and C, but Java kind of evolved from that and became its own thing. So, there's a little history for
Well,
you.
okay, hold on, wait a minute. From what I understand, the Java middle language, what do they call their intermediate or middle language?
Yeah, no problem. So, the intermediate language that Java uses is called bytecode. Basically, when you write Java code, it gets compiled into this bytecode that runs on the Java virtual machine, or JVM. So, that's the middle language that sits between your Java source code and the machine code that actually runs.
Okay, but what built that?
Got it. So the JVM itself, which runs that bytecode, was originally built using a mix of languages, but mostly C and C++. So in a
I'm
sense,
such a
those
C++
languages.
purist. I was just waiting for that. Thank you, Sandra. You have reasserted my knowledge of this world. Okay, that was a good beginning to the day. Java was built by C++. Uh, and well, what started Java? Python, kind of. Python was one of the languages that started Java, and it was this idea. And I'm gonna get into Mr. Scratchy mode here, guys. Sorry, but it cannot be helped if we want to have any context of what the heck I am parroting about. We must do the chicken scratch. Chicken scratch fever. Okay, what was I talking about? I was talking about Java being built by C++ and why it came about. There we go. Okay. So that kind of takes us down to a little bit more on, hey, what is C++? Because after all, Java is built by C++. By the way, Python's built by C, which is kind of C++. It's actually the underlayer of C++. C++ is built on C. The problem here is that if we built a program, and in fact, pretty much the whole Unix, Linux, Mac operating system is done through programs, C++ programs that kind of hand themselves off to each other. If we built a program for a Unix operating system, or for or Mac is Unix, by the way, Linux, all these guys, if we built a C++ program, all these operating systems required us to port the code to its particular way of doing things. And so we would actually have to rewrite the code. And it used to be worse when Mac was kind of its own deal, because then we would have three different, but the idea is that we want to be able to have software that runs on multiple different types of physical architecture, that actually the way the process, the mechanical process happens. And C++ had to be rebuilt. For every program that you created in C++ would have to be ported over, redone to be able to be compiled on that system using the tool chain of that particular system, and be run and debugged and all that stuff. And it just got to the point of silliness. So tools started to be developed that would allow us to run a program that has been pre-created on the operating system. That program is what we call the interpreter. And so the interpreter was created. And what the interpreter does is it looks at a Py file, which is just a program. It's just a program using the Bytecode. And it will take, and it's a pre-built program, and it will look at a Py file with Bytecode. Here will be your Bytecode. And the interpreter itself is a pre-built C++ exe. It's a pre-built C program. And the C program, which is the interpreter, it will read that Py file. And then as it goes through that Py file, wherever we have an instruction for like a loop or a decision tree, it'll see the if statement in Python, and it'll look at the arguments for that if statement, and transfer those arguments into its own implementation of an if statement. So it's just another program that is wrapped. It's wrapped around a pre-built executable that is very generic, and you can throw that stuff in and out. So they're literally just taking an if you write in a Py file and pumping it through to a pre-built if in a C program. And that is what the interpreter is. That's it. That's how an interpreter works. That's Python. Guess what Java is? It's an interpreter. However, Python is an interpreter that is not very object oriented. Java was built from ground up with the idea of an intermediate language to solve these multiple problems, because if you build something in Python, you can rebuild and create a different interpreter for each of these guys. So every operating system type has its own Python interpreter, its own built exe with the tool chains that are proper for it. And all Python does is pump an if statement from one side over to the other. That's interpreters. That's what started the idea of interpreters. So Java, what it has is it has that intermediate language, and that intermediate language, what it does is it's built to run on each of those guys. That's why you have to install your Java SDK JDK, because you're installing the interpreter essentially. And I'm using interpreter word very loose because they use some more real fancy words to describe it, which whatever. But Java has that intermediate language, and what sets it apart from Python is the ability to be object oriented, totally polymorphic. So it took all that C++ dynamic binding polymorphism ideas that you learn in your C++ courses, and it turned it into a language. So when you're learning those high concepts like binary trees, vectors, linked lists, all that stuff, it's all been implemented in one form or another with managed code. And I call Java, Python, JavaScript, all those managed code packages that are built on some form of C or C++ architecture, I call those super languages, because they are at such a high abstract level that there's not a lot of weeds that people have to get into to complete very complex algorithms and tasks. In fact, Python bore the current Google. Python is what made Google a world power. They built their first binary tree web crawler with Python. It's way better at working with data than a lot of other languages. And Python is fast because it's built on top of C. So it's probably one of the better approaches. I don't know what they're using now, of course, but that's where they started. So that intermediate language is built for every different type of operating system. So then all we have to do is come in and write our Java code, and the intermediate language, the JDK, the thing that you install just to run Java, will tell it how to execute on whatever operating system contains the Java toolchain, or Java tools, or Java. That's what Java is. And it's hyper object oriented, polymorphism. And why is it better than C++? C++ is complex and low level. We use C++ to build things like Java. Java is a tool that you can use to get things done quick, working with data science. It's when you don't care about speed. Speed don't matter. it's also when you're not really developing world-changing technologies, because a world-changing technology is always, 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 always about speed, guys. It's always. That never changes. That will always be money in the bank when somebody figures out a way to do something faster. It's just the way it is. All right. Hopefully, this gave you a little bit of a shakedown on what Java is. You may need to, after getting through some of your chapters, come back and rewatch this video, because I'm starting off kind of hot with this one. Let's get into. Let's see, what do we got on my little list here. I want to make sure that we've gone over everything. Okay, Java. What is it? It's an intermediary language built by C++ that that you use to execute Java programs or scripts. You can call them scripts, programs, whatever. What's the middle language? Okay, great. We talked about the middle language. The history, the idea that Python implemented just got extended into Java with up-to-date code and object-oriented programming. It was a and being polymorphic. Oh, I think we are at starting our first program. We've been talking about it for so long. Okay. Yeah. Yeah. Let's do that. Let's do that. All right, it's time to have a little fun, guys. Let's get into the meat of a few things. And that is NetBeans, what you need to get started. And you're going to install that. Now, of course, guys, you're going to need to install the JDK files for the NetBeans interpreter, because NetBeans was built on Java. So the application itself, the IDE, the software development NetBeans app was built using Java. So you have to have Java installed to run NetBeans. So you're going to download the NetBeans, the Oracle Java JDK or whatever, not SDK but JDK, but yeah. And then so you can go here to download NetBeans, the recent version. They've Apache took them up, and then this is what you want to do before you download NetBeans. You want to download Java JDK. This is the interpreter, guys. This is what you need to just run Java apps. You probably might already have it installed if you use some Java apps from other things, but this will install for you to be able to do Java programs. And then then you install NetBeans, run it, and then you get what I'm going to show you now. And of course, there's directions, guys, that I've got for you guys to. You can find stuff out there. I want to show you how to build your first Java app. That's my goal for this video, and then of course go over some class characteristics next. Don't worry, we got all quarter to interact and have fun with NetBeans. So once you get NetBeans started up, you may have to go over here to Tools, Plugins, and add the Java plugins, and then once you hit add, you install, and then I believe Tools. Yeah, plugins should get you what you need. You can look at just available plugins, and then you can type in, I think, Java, and it'll bring up, like here's one Java. I don't know what it is, but it'll give me uh, something. If you have no menu options to create a project like I'm going to show you, then this is where you need to go and click on things that say Java to install, and then click install. And then it will install that particular plugin, because NetBeans is able to do multiple languages. It does PHP. It's kind of like Visual Studio Code. Visual Studio Code is actually a really good way of doing Java as well. I just haven't really gone over to it yet, even though I now use it for C++. I went away from, at least for my own stuff, Visual Studio. And I'm using Visual Studio Code for straight up C++ development now. Apache NetBeans is the same idea that Visual Studio Code, and it's able to do multiple languages. And Java is really it's a fair implementation. I've got issues with it, but then again, I've got issues with a lot of things. So whatever. Okay, once we're into our NetBeans here, we got our plugins. We should, if we have our plugins correct, when we go here to File, New Project, what it should say is it should give you the ability to choose something that says Java with Ant. Okay, and we just want a regular, I believe, hopefully I don't mess this up, because they always change it. Of course they always change it. I think this is good. I think this should get us what we want. There we go. We just want a standard console-based application. That's it. And that usually starts within some particular files. And that is to solve some problems with variables, such as this idea of a package. Package is a namespace. and that stuff will be unfolded as we progress, and we'll talk about each of these things. But a package is what's going to contain code, and the starting place of an application or a process is always in main. And so our application, our process, is going to start right here, and then it will mechanically work its way top down. So I believe system.print all right. Well, this is just going to be a simple print. I believe I might be missing something here. Is it console? No. Let's go to my system out. Yeah. Okay. System.out. And print line. That'll do it. Print line puts a \n character, which is a new line terminator. And I might be missing an include or some kind. Okay, no, that's good. That actually runs it. And one thing that we're going to be doing is we're going to be setting breakpoints. So you see, I just clicked over here, and this red showed up. And what I can do is I can debug, and I can have the process stop there, so that I can examine and step over and step through the code and see exactly what's going on behind the scenes. Now, this is going to be a base skill that I'm going to be showing you guys implicitly that you must, did I say must? You got to debug. If you don't, if you use the, oh, let's just print a line here for debugging method, the learning curve that you're going to have is going to be reduced by a magnitude of let's just say that your the social life that you would live with debugging is your best life. I'm telling you, debugging is your friend. I mean, especially when I walk outside, I debug all the time. Oh, nah, too much. All right. That means we move on when Professor B starts doing stuff like that. It is time to move on. All right. Now we get to the boring parts, the fiddly bits, because we're going to be doing chapter 1 here coming up and talking about some things uh, and getting into more. We're going to be diving right into it. So, with that being said, fiddly bits. Your module zero assignment. Now the formatting of this is this. Your first module 0 is kind of more up to date with what I'm initially going to be doing eventually. But the main thing here is to take note of your you know that you have an assignment and they are scenario based. And when you go to your modules and progress to each assignment, it's going to lay out everything that you need to complete for that assignment. And as far as grading, the evaluation criteria, I would actually, when I have this updated, this would actually be in the assignment up above here. But here's what I'm looking for, guys. And I'm not here. Okay, let's start. Let's start with this. I'm looking for you to show me what you learned and how you learned it. I want a story. And have fun with it. It can get wacky. Sometimes I've never laughed harder. I mean, really, some of the stuff I see is just precious gold. And artificial intelligence, embrace it, but don't use it to solve the problem. Use it to solve parts of the problem or help you with parts of the problem. Because if you use it to solve the problem, all of the problem, you're going to get no benefit. And then also, of course, sometimes that thing gets a little insane and does stupid things. and then, and then, you know, if I see assignments that I can't understand the code, there's only one place that comes from, guys. Really. So try to make it genuine, make it yours. I want you to use the AI because that's the future. Really. I now no longer I put chunks of code together that are written by the AI and that I massage and fix and throw in. And so writing code and doing work is now totally different because all the fiddly bits are taken care of for us. Use the AI for the fiddly bits. Don't overuse the AI because it's not going to help you when you get to the complex problems. It's not going to help you understand the solutions that it has for those complex problems. So it's not a good place to start the learning. Struggle, use it for parts of the problem. Ask it to teach you parts of what you need to know to solve the problem. That is a really good one. So yes, embrace it. Use it wisely, like anything, whatever. Show me a story. Show me a story. Document challenges that you had completing it. I want you to, document what steps you took to complete it. You can do that documentation all at the end and a little summary of the program. You can do it through the program as comments, but tell that story. Make sure that your code has the quality standards that we discussed in our first discussion. Pick one of those naming conventions. Try to keep your input validation clean. I don't get too persnickety on that though. I'm kind of lazy myself, but guys, input validation, no software can be put or released without it. It just can't, because it's unusable. All right. Tell me that story, please. I want to hear your struggle. I want to hear the pain, because I had a lot. Oh, the pain. Oh, the pain. Oh my God. Hours and hours, guys. 9 hours a day for years. 9 hours a day for years. Yes. Yeah. Horrible. That was for C++. But once I learned that, I knew every language. So it was worth it. And that works kind of with every language you learn. Once you know one, you kind of know them all. Sort of. All right. Class characteristics. What you got to do. How things are done. Complete your programs. Your homework. What I want to see is, let's see. I want to see your code. Put your code as text. So you're going to copy the code as text. Copy as text. You're going to put that right into a document, Word, PDF, or whatever. Then you're going to take a screenshot. You're going to take a screenshot. You can hit print screen. You can use Mr. Snippy down here. Mr. Snippy, type in SN, and it brings up the snipping tool. You can take a screenshot of your console output, guys. That you're going to copy, and you're going to put right below. That's kind of weird. I just got really silly. Your console output. Well, let's show you what your console output is. Actually, that would be better. Okay, I'm going to give you exactly what I want to see when you turn this in. So let's say we're turning this in as an assignment. I'm going to put in my code. And I'm going to say, I got NetBeans working and it ran well. I didn't have any issues other than, I don't know, whatever. And then maybe describe, because, of course, I'm not going to have any issues. Oh my goodness, that's a narcissistic statement. Oh, boom, boom. No. And I didn't have any issues. Okay, so whatever story you got to tell, you can put it right underneath. You can put it through here. I expect a little bit more than, 3 sentences. Describe this, or, give me a story per code line. That's even better. I love that. Kind of like in sequence with the code. And appropriate language is definitely optional. All right, screenshot of the program. So we're going to go in and we're going to run the program. I'm going to hit play. It's going to run and it's going to output. Now it's going to either pop up a console, or we're going to look down here in the console output that pops up for us, and we're going to see the hello world output. And what I'm going to do is I'm going to take Snippy and I'm going to say Mr. New here, and I'm going to screenshot that output. I'm going to copy it by hitting Control C, and then I'm going to go over here to Mr. Word, and right after or before, it doesn't matter. You can put it. You can put it down below. You can put it up above, whatever. But this is the code that you wrote as text, not a picture, not an image of the code, guys. I don't want an image of the code. I need the code. I need the actual text. And then a screenshot and an image showing you run it through its testing, showing that it works, and through each permutation. You don't have to get crazy though. I mean, you can generally show me that it works and you're okay. All right. This is how I want to see an assignment. This is how I want to see one programming assignment submitted as text with a screenshot of it running. And you will use, for multiple programming assignments for the week, just use the one document. So you can throw in, like number 20 here, and then you can do the next scenario, number 22 or whatever, the number 1 scenario, then you got number 2 scenario, number 3 scenario. You can all do that throughout the one file. All right. What's next? Yeah, assignments. That's right. I got off on a tangent. I was heading that direction, but I kind of got in the weeds. All right, here's the way the grading is based as far as how it's broken down on assessment. Your assignments are 25% of the total grade. Discussions are 15. Quizzes are 10. Midterm is 20, and the final is 30. Your hands-on final, did I make that a hands-on? I don't know. I might have to figure out what I got going on there. Okay, let's look at your midterm. I believe your midterm is based on, your midterm is based on your quiz questions. And your quiz questions come from your book. And you have a final exam that is hands-on. That it looks like I've got to modify. It'll be a hands-on exam, and you'll have a study guide. As far as the midterm is concerned, your study guide for the midterm is your quizzes. So that's your weekly quizzes, because your midterm's based on those weekly quizzes. And then you won't have any of those type of questions for your final, because I'll have you write a program for your final, and so then you will submit that program. It'll be a hands-on performance-based exam. Midterm, you can prepare for it through your quizzes or through this practice exam that I threw up, so that you can get exposure to all the questions in the question bank. Yeah, I think that's pretty much the outline of the course. And I'm looking forward to talking to you and describing each chapter and interacting and demoing with you as we progress through the book and the quarter. So, all right, guys, thank you so much. Bye.